Quantitative process analysis is concerned with different performance measurements of the process. Again, consider the example of the construction site and the site engineer ordering equipment. Would you prefer the service that delivers the equipment very fast? Or would you prefer the service that delivers the equipment very cheap? Or would you prefer a service giving you the equipment that very well fits your requirements? These questions point to different preferences that you may have in terms of choosing a particular service. And they are related to three very important process performance measures. These are time, cost, and quality in the end. For each of these different dimensions of process performance, there are different methods in order to investigate them. Here at this stage, we focus on flow time analysis and on simulation. Flow time analysis tries to answer the question, how long does it take on average to perform a process? This is a simple question if you have a sequence of activities. If you have an activity A that takes 10 minutes, and you have an activity B taking 20 minutes, the average flow time is the sum of them, which is 30 minutes. Many processes are not just fully sequential, they have alternative paths, because there are decisions in the process. Consider now the case that you have activity A taking 10 minutes, activity B as the first alternative taking 20 minutes, and activity C taking 10 minutes as the second alternative. Now, when executing the process, a choice has to be made between activity B and C. If we know the probability, 90% here in this case for B and 10% for activity C, we can calculate the average cycle time as the duration of those activities weighted by the probability. Therefore, we have an average cycle time of 29 minutes here in this case. Consider now the case where we have paths that are parallel. We again have activity A taking 10 minutes, but then there are two activities, B and C, which can be executed concurrently. For calculating the average cycle time, we have to wait for the slowest unit to complete. This means we can only complete the process when the slower unit of activities B and C has completed. Therefore, we have to consider the maximum time from B and C, and here in this case, this is 20 minutes. That means altogether the average cycle time is 30 minutes. But what happens if we observe a rework loop? At different stages it may be that we have to repeat activities in the process. Here we see an example where this is exactly the case. In order to calculate the average cycle time here, we have to consider the probability of exiting this loop. That means moving rightwards to continue the process. Here in this example, this is 80%. We have to divide the duration of the activities in the loop by this probability of 80%. This means the overall cycle time here for this example is 35 minutes. Flow time analysis works very nicely if activities always have the same duration and the same probability to be executed. In many practical examples, this is not the case. Therefore, we often make use of process simulation. We can do an as-is analysis, but also a what-if analysis. In order to make process simulation work, we not only have to know the average cycle time of each of the activities, but we also need to know the availability of resources. We need to know the statistical distribution of, for instance, the arrival times and the probabilities of certain activities to happen. With all this statistical information, we can build a complex model that we can simulate. The simulation has the advantage that we can play with different parameters. And in this way, the process analyst may find the optimal configuration for a particular process. This works as follows. We create a large number of instances for the process which are generated by our simulation environment. By running these instances, we get information on how long they take, how much resources they consume, and how much costs they entail. If we sum all this data up, we can apply statistical methods in order to calculate these performance measures. In this way, simulation offers us the possibility to analyze also complex processes with contextual factors.